So today we're going to discuss about negative powers of exponents. Negative power must become positive. Negative power is not permitted. It's not considered simplified form. Therefore, to remove the negative power, if the algebraic expression with the negative power is on the numerator, you must move it to the denominator to make the power become positive. You must do the same if the negative power is on the denominator. You must move it to the numerator to make the power become positive. Example number 1. If you are given a to the negative 2 over b to the negative 3, this must look like where you move the numerator to the denominator and turn the power into positive. And in the case of b, since the power is negative 3, you're also going to move it on top. And now when you move it on top, it turns to a positive. And your final answer would be this, because you cannot anymore combine or cancel out any like terms. So what do we, if we have example number 2, a to the negative 2 over b to the power of 3. You all know that the power of 3 is okay because it is positive, and this is the only term that we need to bring down because it is negative. When you bring this down, please take note that there's a 1 in front of the a. Because there's a 1 in front of the a, it would look like this. So you put your fraction bar. What's going to be left on top is the 1, because you're taking the a at the bottom, and then your b is here, and you can either have that or 1 over a squared b to the third. Example number 3 is negative a to the power of negative 2 over b to the power of 3. Once again, the negative power is not permitted, but you all know there's a negative 1 in the front of a to the power of negative 2. Therefore, what's going to be left on top is a negative 1, and at the bottom will be a squared b to the third. Or, if you have negative over positive, the whole fraction becomes negative. Therefore, you put the negative bar at the very middle of your fraction and put 1 over a squared b to the third. Example number 4 is a to the fourth b to the negative 3 all over b squared. So when we look at this, the only power that's not permitted is the b that's in the numerator, because it has a negative power of negative 3. And so what's going to happen is we must move that. Everything else stays where they are, except that this moves down. So this will now become a to the fourth on top, b to the power of 3 now, because it will turn to a positive, and b squared has been there. We're not moving that because it's positive. Therefore, your final answer is going to be a to the fourth, b to the fifth. Our example number 5 is a to the fifth over a to the negative 4. As you can see, the denominator has a negative power and it is not permitted. Therefore, what's going to happen is we're going to move the a to the negative 4 on top together with the a to the fifth. But you all know there's a 1 in the front. Therefore, this would look like this. A to the fifth times a to the power 4, and that's a 1. By the way, just to emphasize, all of these guys are times. Those are times, okay? That's times right there. Okay. So now this is going to look like a to the ninth all over 1, better known as a to the ninth. For our last and final example, sixth and final example, we have a to the negative 7, b squared, c to the negative 4, a to the negative 2, c to the negative 4 over a to the negative 2, b to the negative 1, c to the negative 4. And this would all look like this. A squared switches with a to the 7th, and they will become positive. B squared stays on top and will be joined by b to the first. Well, this one, will cancel out because it's c to the negative 4 times all over itself. So something divided by itself except for 0 is going to be equal to 1. However, I still want to show you that this will go up and this will go down, and they will turn positive. Okay, so now this becomes, there are 2 a's on top, 7 a's below, so I will cross this out, and this will turn to a to the 5th, and no more a's on top. The b will turn to a3, and the c4 will cross out. Oh, this is my final answer.